In question 1, we need to solve the inequality here. So we start by collecting the x's on the left-hand side and all the numbers on the right-hand side. So we have 7x less than 8 plus 27. So it's 7x less than 35. I will be dividing both sides by 7. So we have 7x over 7 and 35 over 7. And so x is less than 5. In 2, we need to write 124 as a product of its prime factors. So I will keep dividing 124 by prime numbers until I end up with 1. So 124 divided by 2 is 62. 62 divided by 2 is 31. 31 is a prime number. So 124 is 2 squared times 31. In question 3, we've got 160 cars and vans in totals. They are in the ratio of 3 to 7. Now, each car and each van uses electricity, diesel, or petrol. An eighth of the cars uses electricity and 25% of the cars uses diesel. We need to work out the number of cars that uses petrol. I will start by finding the total number of cars. So we've got 3 plus 7. We've got 10 parts in total. And for the cars, we know that 3/10 of 160. Now 10 with 160 simplify to give me a 16 here. So 3 times 16 gives me 48 cars in total. Now for electricity, we know that an eighth of the cars uses electricity. So 1/8 of 48 is simply 6. And then for diesel, we've got 25% of the cars. So 25 over 100 times 48. Well, 25 over 100 simplifies to a quarter, and a quarter of 48 is 12. So we've got a total of 6 and 12. We've got 18 cars that use electricity or diesel. We're looking for the number of cars that use petrol. So we will be doing 48 minus 6 plus 12, which is 48 minus 18, which gives an answer of 30 cars that use petrol. In question 4, we need to write 1.63 times 10 to the negative 3 as an ordinary number. This is 0.00163. And then we need to write 438,000 in standard form, where that would be 4.38 times 10 to the power of 5. Then in part C, we need to work out 4 times 10 to the 3 times 6 times 10 to the 5. So let's write what we need to calculate here. 4 times 10 to the 3 times 6 times 10 to the negative 5. I will be doing numbers with numbers and the powers of 10 with powers of 10. Well, 4 times 6 is 24, and 10 to the 3 times 10 to the negative 5. When I've got multiplication with a common base, I add the indices. 3 and negative 5 is negative 2. So this is 24 times 10 to the negative 2. We have been asked to give our answer in standard form. So this will be 2.4 times 10 to the negative 1. In other words, I divided 24 by 10 to make it 2.4, so that it sits between 1 and 10 as per the standard form requirements. And because this was divided by 10, the power of 10 here increases by 1 and goes from negative 2 to negative 1. In question 5, we've got a regular hexagon and a regular pentagon, and we need to work out the size of angle X. I could start by labeling this angle here, the interior angle of the regular hexagon, as theta, and the interior angle of the regular pentagon as phi. Now for the regular hexagon, we know that the sum of the interior angles is 6 minus 2 times 180. It's always the number of sides minus 2 times 180. This is 4 times 180, which is 720, and therefore theta will be 720 divided by 6, which is 120 degrees. Similarly for phi, it's the pentagon, so the sum of the interior angles will be 5 minus 2 times 180, which is equal to 3 times 180, which is 540, and therefore phi will be 540 divided by 5, which gives an answer of 108 degrees. So to find x, I will simply use the fact that theta, phi, and x are angles at the point, and therefore they add up to 360. So x is 360 minus the 120 plus the 108, which is 360 minus 228, which gives an answer of 132 degrees. Now, an alternative way of approaching this is by considering the exterior angles. So we draw the line here, and we can see that this angle here, which I could call alpha, is the exterior angle of a regular hexagon. So this will be simply 360 divided by 6, which is 60 degrees. We know that the exterior angles add up to 360 always, irrespective of the number of sides. We've got a regular hexagon, so all exterior angles are the same. So we can find the size of one exterior by dividing 360 by 6. So that's 60. And then over here, we can call this vita. It's the exterior of a regular pentagon. So it's going to be 360 divided by 5, which is 72. And therefore, we can conclude again that x will be 60 plus 72, which is 132 degrees. In question 6, we need to complete the table of values for y is x squared minus 3x plus 1. Well, if x is negative 1 squared will be 1, minus 3 times negative 1 plus 1 will be 1 plus 3 plus 1, which gives me 5. For 0, we've got the answer. For 1, we've got the answer. When x is 2, it's going to be 2 squared minus 3 times 2 plus 1, which is 4, minus 6 plus 1, which is negative 2 plus 1, which is negative 1. And if I proceed, for 3, it will give me 1, and for 4, it will give me 5. And therefore, I can proceed into plotting the points and joining them with a smooth curve to see the graph of this quadratic. So there it is. We have plotted the points. We join them with a smooth curve. This is the graph of y is x squared minus 3x plus 1. And we can now proceed into using our graph to find estimates for the solutions of the equation x squared minus 3x plus 1 is 0. These are the points that we cut through the x-axis, and we can easily see that this is 0.4 and this is 2.6. So our solution will be that x is 0.4 or that x is 2.6. It's also worth mentioning that the examiner here is accepting anything between 0.3 to 0.5 for the first solution and 2.5 to 2.7 for the second solution, provided this follows through from your graph. In question 7, we've got two cubes A and B. A has a side of 3 centimeters, B has a side of 4 centimeters. We are given the masses of the two cubes, and we need to work out the ratio of the density of A to the density of cube B. Let's start by reminding ourselves that density is given by mass over volume, and it will make sense to draw up a table here to have all the information. So we've got cube A, cube B. The masses are given. It's 81 grams for A and 128 grams for B. And then the volume of A is simply 3 cubed, which is 27 cubic centimeters. And for B is 4 cubed, which is 64 cubic centimeters. To find the density, we do mass over volume. So 81 over 27 gives an answer of 3 grams per cubic centimeter. And for B, it's 128 divided by 64. This gives an answer of 2 grams per cubic centimeter. So it's easy to see that the ratio of the densities is 3 to 2. In 8, we've got the amount of snow in centimeter that fell each day for 30 days. It's a grouped frequency table, and we need to work out an estimate for the mean amount of snow per day. We'll start by adding an extra column here, the midpoints. So the midpoint of the 0 to 10 class is 5. It's the midpoint of the 0 and the 10. then it's 15, then it's 25, then it's 35, and then it's 45. The idea is that because these 8 observations are between 0 and 10, the most fair thing we can do is assume that all 8 of them are exactly halfway through this class, so they are at 5, and similarly for the remaining classes. So the mean will be found by multiplying frequency by midpoint and dividing by the total number of days, which is 30. So it's going to be 8 times 5 plus 10 times 15 plus 7 times 25 plus 2 times 35 plus 3 times 45, and all of it over 30, the total number of days. So we start by doing the calculation. 8 times 5 is 40, 10 times 15 is 150, 7 times 25 is 175, then it's 70, and then it's 135, all of it over 30. We can now pair up the 40 with the 150, they give me 190. I can also pair up the 175 with the 135, they give me 310, and then the 190 with the 310, they give me 500. So the only number missing is the 70 here. So 570 is 570 over 30. The 3 with the 57 gives me a 19. The 0 with the 0, they cancel out. So the answer is 19 centimeters per day as the estimated mean. In question 9, we've got a cube placed on top of a cuboid as shown in the diagram below. We need to work out the total surface area of the solid. So we need to consider carefully the different faces that we're dealing with in order to come up with the total surface area. I will start by considering this part here. So I have shaded this part here, and if you notice, the middle part here does not constitute part of the surface area. However, it is exactly the same as the part which is here. So if I just calculate the total area of this rectangle here, it means I would have accounted for all of this part plus the top part here. And similarly, there is another part here at the bottom. So up to now, with regards to the total surface area, we've got 2 times the 7 times 6. So we have accounted for all of these, the top here and the very bottom. We can now look at the cube on the top of the cuboid, and we've got these 4 faces all around. So I have erased anything I've shaded up to here. Let's look at what we have around this cube here. We've got 1, 2, 3, 4, and each of these has an area of 4 times 4. Remember, it's a cube. So we've got 4 identical faces, each one having an area of 4 times 4. And turning our attention to the cuboid, we've got this face here which measures 5 times 6 and an identical face here. So these are the 2 faces. So we've got 2 times 5 times 6 contributing to our total surface area. And finally, it's the face here which measures 7 by 5, for which we've got an identical face at the back that measures also 7 by 5. There they are, shaded in green. So this is 2 times 7 times 5. So if we add this up, we will be getting the total surface area. So this is 2 times 42 plus 4 times 16 plus 2 times 30 plus 2 times 35, which is 84, plus 64, plus 60, plus 70. Now the 60 with the 70 give me 130. The 84 with the 64 give me 148. So in total, we've got 278 squared centimeters. In question 10, we've got the profit made each day at the cricket club on 100 days, and we need to complete the cumulative frequency table below. So we start with 10, Then 10 plus 15 is 25. If we add another 25, we go to 50. Plus 30 is 80, then 85, then 100. Remember that the final number on a cumulative frequency table should be the total frequency, which was given to be 100. In part B, we need to draw the cumulative frequency graph. So we start by plotting the cumulative frequencies against the class endpoints, and we join them with straight line segments. Remember that the examiner is also accepting you joining them with a smooth curve. However, it's easier if you just join them with a straight line between the consecutive crosses. And then in part C, we need to use the graph to find an estimate for the number of days on which the profit was less than £125. Well, £125 is here. So if we go up and to the left, we can read off the value of 38 here. So 38 days is the number of days for which the profit was less than 125 days. The examiner here is accepting anything between 35 to 39. In D, we need to use the graph to find an estimate for the interquartile range. Now for Q1, I will do a quarter of 100, which is 25. For Q3, I will do 3/4 of 100, which is 75. So I will go to my graph here. I will go from 25, which is somewhere here, and then down, and then from 75 and go down to read Q1 and Q3. So there it is. We can see that Q1 is 100, Q3 is found at 192 over here, and therefore the interquartile range, which is Q3 minus Q1, will be 192 minus 100, which is 92. The examiner here is accepting anything between 85 up to and including 93. In 11, Comac has some sweets in the back. They are lime flavored or strawberry flavored or orange flavored. So we've got 3 flavors. These are the number of different sweets, their ratio, and if they're gonna take at random a sweet from the back, we know that the probability that they take a lime flavored sweet is 3 to 7. So we need to work out the value of x. Well, I will start by saying that the total here in terms of the parts of the ratio is 9 plus 4 plus x, which is 13 plus x. And therefore the probability we take a lime will be 9 over the total, so 9 over 13 plus x, and we have been told that this is equal to 3 over 7. I will cross multiply. 9 times 7 is 63, and this is equal to 3 times 13 plus x, so 63 is 39 plus 3x. 63 minus 39 is equal to 3x. Now 63 minus 39 is 24 is 3x, and therefore x is 8. In 12, we are asked to express 0.1171717 as a fraction. I will start by saying let x be 0.1171717. Remember that the dots over the digits indicate the start and the end of the pattern. The first one here is not part of the pattern, so 10x will be 1.171717. So I now have the decimal part being constituted only of the pattern. So if I multiply this by 100, leading to 1000x, it's going to be 117.1717 ... And we observe that the decimal part here and here is identical, which means that I could deduct one from the other. 1000x minus 10x is 990x, which is 116. So x is 116 over 990. You could simplify this to 58 over 495. However, if you decide to stay here, that will be acceptable. You will not be penalized. In 13, we've got a right angle triangle formed by the diameters of the 3 semicircular regions. we need to show that the area of A is equal to the area of B and C. I will start by calling the three sides of the triangle here 2A, 2B, and 2C. In other words, A is the radius of this semicircle, B is the radius of this semicircle, and C is the radius of this semicircle. Now, Pythagoras' theorem tells us that 2A all squared is equal to 2B squared plus 2C squared, since 2A is the hypotenuse. So 4A squared is 4B squared plus 4C squared, which leads to A squared is B squared plus C squared. And now I could consider the area of B plus the area of C. So the area of B is a half times pi times B squared. Remember that the formula for the area of a circle is pi r squared, where r is the radius. In our case, B is the radius. It's a half because it's a semicircle, plus a half pi c squared. I will factor out the half pi, and I'm left with the half pi brackets B squared plus C squared. Now from Pythagoras, B squared plus C squared is A squared. So this is a half pi A squared, which we can easily recognize as the area of A as required. In 14, we've got a speed time graph, and we are asked to work out an estimate of the gradient at t is 2. So at this point here, we draw a line that just touches, and we identify 2 points which we're gonna use to find the gradient. This point here has coordinates 5, 5.7, and the cut here on the y-axis is at 0.9. So the gradient will be found by doing y2 minus y1 over x2 minus x1, which in our case leads to 5.7 minus 0.9 over 5 minus 0. So this is 4.8 over 5, which is 48 over 50, which as a decimal is 0.96. The examiner here is accepting anything between 0.7 up to and including 1.1. In B, we are asked what does the area under the graph represent, and we know that when we've got a speed time graph, the area under the graph is simply the distance that has been covered. In 15, we've got the vector AB and the vector AC, and we need to prove that A, B, and C lie on a straight line. So we start with AC being 15A plus 20B as given in the question. We notice there's a common factor of 5, so this is 5 times 3A plus 4B, and we notice that 3A plus 4B is exactly the vector AB. So this means that AC is 5 times AB, and therefore we conclude that AC is parallel to AB. We also notice that A is a common point, and therefore this leads to the conclusion that A, B, and C lie on a straight line. They are said to be collinear points. In part B, we need to work out the ratio of DF to DE. We've got the vector DE and the vector EF. So we start by saying that the vector DF is simply DE plus EF. Well, DE is 3E plus 6F, and EF is minus 10.5, E minus 21F. So this leads to minus 7.5 E minus 15F. So I can factor out the minus 2.5, and I'm left with 3E plus 6F in the brackets. So this is minus 2.5 times the vector DE. And therefore this means that the distance DF is 2.5 times the distance DE. Notice that we drop the negative sign because distances, lengths are always measured in a positive sense. So we have that DF df over de is 2.5. I can see this as over 1, and therefore the ratio of df to de is 2.5 to 1, which can be written as 5 to 2. The examiner is accepting both of these as correct answers. In 16, we've got a first aid test that has two parts, the theory and the practical test. The probability of passing the theory test is 0.75, and the probability of passing only one of the two parts is 0.36. The two events are independent, and we need to work out the probability of passing the practical test. It makes sense to draw a tree diagram here because we've got two stages, the theory and the practical test. We know that the probability of passing the theory is 0.75, so the probability of failing is 0.25. Now for the practical, I will call P the probability of passing and 1 minus P of failing, and similarly here P and 1 minus P. And we have been given the probability of passing exactly one of the two tests, so I could either pass the theory and fail the practical, or fail the theory and pass the practical. So we know that we multiply the probabilities of the branches through which we travel and we add them up. So 0.75 times 1 minus P plus 0.25 P is equal to 0.36. I will expand 0.75 minus 0.75 P plus 0.25 P is 0.36, which leads to 0.75 minus a half P is 0.36, and therefore 0.75 minus 0.36 is 0.5 P, which leads to 0.39 being 0.5 P. I multiply everything by 2 and I get 0.78 for the value of P. This is the probability of passing the practical test. In 17, we've got y being directly proportional to the square root of t, and when t is 9, y is 15, and then t being inversely proportional to the cube of x, and when t is 8, x is 2. We need to work out a formula for y in terms of x. So we start with y being proportional to the square root of t. So y is k1 root t. We have that y is 15 when t is 9. So I substitute y with 15 and t with 9, and we get 15 is k1 root 9. So 15 is 3k1, so 5 is k1. So we have just established a relationship between y and t. Y is 5 root t. Similarly, t is inversely proportional to the cube of x, so t is k2 over x cubed. Now when t is 8, x is 2, so I will substitute to get 8 is k2 over 2 cubed. Now 2 cubed is 8, and therefore we get that k2 is 64. So this leads to t being 64 over x cubed. We need to connect together y with x, so we can say that y is 5 times the root of t, which is 64 over x cubed, which means that y is 5 times the root of 64, which is 8, over the root of x cubed. So y is 40 over x to the 3 over 2. In 18, we need to work out the value of this expression here. So we start by expressing 5 and 4 over 9 as an improper fraction. It's 49 over 9 to the minus a half, times the 4 and 2/3, it's 14 over 3. And then 2 to the negative 3 in the denominator can be written as 2 cubed in the numerator. Now 49 over 9 to the minus a half can be written as 9 over 49 to the half, times 14 over 3 times 8, which is 2 cubed. Now the 9 over 49 to the half is simply the square root of 9 over 49 times 14 over 3 times 8. The root of 9 is 3. The root of 49 is 7 times 14 over 3 times 8. We've got the 3 with the 3 cancelling out. The 14 with the 7 leaves me with the 2 in the numerator. So all in all, I've got 2 times 8, which is 16, as a final answer. In 19, we need to solve the given equation, giving our answer in the form p plus minus root q over 2. So from the form of the answer, I'm guessing we will be using the quadratic formula. So let's start with the given equation. It's 1 over 2x minus 1 plus 3 over x minus 1 is equal to 1. We note that the LCM here is 2x minus 1, x minus 1. So the first fraction will be multiplied by x minus 1, the second by 2x minus 1, and the third, which we can see as 1 over 1, needs both the 2x minus 1 and the x minus 1. So this leads to x minus 1 plus 3 times 2x minus 1 is equal to 2x minus 1 times x minus 1. We will expand, getting x minus 1 plus 6x minus 3 is 2x squared minus 2x minus x plus 1, which leads to 7x minus 4 is 2x squared minus 3x plus 1. I will be collecting everything on the right hand side, so 0 is 2x squared minus 10x plus 5, and I will be using the quadratic formula with a is 2, b is negative 10, and c is 5. So we have that x is minus b plus minus b squared minus 4ac square root, and all of it over 2 times a, which is 2 times 2. So this means we've got 10 plus minus 100 minus 4 times 2 times 5 is 40. So it's 100 minus 40 in the square root, all of it over 4, which simplifies to 10 plus minus root 60 over 4. I can express root 60 as root 4 root 15, and this is going to be over 4. So we've got 10 plus minus 2 root 15 over 4. Notice that there's a common factor of 2 in the numerator, so it's 2 bracket 5 plus minus root 15 over 4, and then the 2 with the 4 simplify out, leaving me with a 2 in the denominator. So final answer is that x is 5 plus minus root 15 over 2. In 20, we've got a circle centered at minus 1, 3. We've got a point with coordinates 6, 8 lying on the circle, and we need to find the equation of the tangent to the circle at A. It certainly makes sense to draw a quick diagram to see what's happening. So there it is. We've got the circle. It's centered at minus 1, 3. Somewhere here it's the point A. I could join the 2 points together. The blue line is the radius, and I'm trying to determine the equation of the red line here, which is the tangent at the point A with coordinates 6, 8. The center is minus 1, 3. We know that the tangent with the radius at the point of contact form a right angle. So I will start by finding the gradient of the radius. So I'm using here y2 minus y1 over x2 minus x1, and in our case it will be 8 minus 3 over 6 minus minus 1, which gives me 5 over 7, and therefore the gradient of the tangent, I will flip and change the sign. It's going to be minus 7 over 5. In addition, we know that the straight line passes through this point here, the point A, with coordinates 6, 8. So we are looking for the equation of a straight line, y equals mx plus c. We have already established that the gradient m is minus 7 over 5. And we know that when x is 6, y is 8. So I will use this to find c. So 8 is minus 7 over 5 times 6 plus c. So 8 is minus 42 over 5 plus c. I will multiply everything by 5 to get 40 is minus 42 plus 5c. So 82 is 5c, which means that 82 over 5 is the value of c. Now go back to the equation of the straight line. Y is minus 7 over 5x plus 82 over 5. I need to give my answer in a particular form, everything on the left hand side, all the coefficients being integers. So I will multiply everything by 5. 5y is negative 7x plus 82, and therefore 5y plus 7x minus 82 is equal to 0. In 21, we've got three circles centered at A, B, and C. All three circles have a radius of 4 centimeters, and we need to determine the total shaded area shown here. I will start by joining together A with B and B with C, and also with the points of intersection between the circles. And we see that this forms two triangles with sides being 4 centimeters. So we've got two equilateral triangles formed here. So if we draw this here, we see that this is 60 degrees, this is 60 degrees, and this here should also be 60 degrees. If I find the shaded area here and deduct this part here and here, then I will be finding the top part. So all that remains to be done is for me to double this in order to get the final answer. So we will find the area of this sector, and we will be deducting the area shown here shaded in red and blue. So let's start with the sector here. We've got the angle is 60 degrees. We know that the radius is 4 centimeters. So this sector has an area of 60 over 360 times pi times 4 squared. Remember, the formula for the area of a circle is pi r squared. This sector occupies 60 out of 360 of the full circle. That's why this formula is giving me the area of the sector. Now 60 with 360 gives me a 6 here. So this is 16 pi over 6, which simplifies to 8 pi over 3. Now I will find the area here, and I will double it so that I account for the blue part here as well. So this here is a segment. I will do this sector and deduct the area of the triangle here. So the area shown shaded here in red and blue is 2 times, and we've got the area of the sector, which is 60 over 360 times pi times r squared minus a half a b sine of the angle, which is 60 degrees. So we know that 60 over 360 simplifies to leave me with a 6. So this is 2 brackets 16 pi over 6. Now 4 times 4 is 16, over 2 is 8. So it's minus 8, and sine of 60 is root 3 over 2. So this is 2 brackets 8 pi over 3 minus 4 root 3. And if we expand, we get 16 pi over 3 minus 8 root 3. So 8 pi over 3 that we found on the left minus 16 pi over 3 minus 8 root 3 will give me the top part here, this part here. So the total shaded area will be twice this. So I will be doing shaded area is equal to 2 times the difference between 8 pi over 3 and 16 pi over 3 minus 8 root 3. So this is 2 times 8 pi over 3 minus 16 pi over 3 plus 8 root 3, which is 2 times minus 8 pi over 3 plus 8 root 3. 2 times 8 root 3 is 16 root 3. And 2 times minus 8 pi over 3 is minus 16 pi over 3 squared centimeters.